Hey there, my pre-calc brethren. Today we are going to be looking at polynomial functions and complex zeros. All right, so I think you all know how to find the square root, and we've seen I before. The biggest thing we got to remember is square root of -1 equals I, and I equals the square root of -1. For example, when we evaluate square root of -9, we do square root of -9, split up into 9 and -1. Split those apart because we can do that over radicals. We get 3i as an answer. Okay. If you need more help with that, look up more videos about explaining imaginary numbers. Okay. Okay. Ooh, what's this pen tool? I wonder if it's good. We'll try it. So, an imaginary number is when one's by itself. A complex number is in the form of a plus bi, where a is the real part, so it's a mix of real and imaginary. It's like me hanging out with Santa Claus. And bi is the imaginary part. It's all fictitious in my head. Okay? So, let's talk about the fundamental theorem of algebra. We're going to put the fun back into it, or the mental. We'll find out. Are we going to put in the mental? Or are we going to put in the fun? What the fundamental theorem of algebra guarantees is that any polynomial function can be factored into that form given how many complex zeros it has. Ay. All this says is that you can get, let's just do an example. Let's see what it means. I hope they never ask you to repeat that definition. I hope no one watches this video and judges me upon my terribleness. All right, let's factor this beast completely. Oh no, mamma mia, trinomial. I don't remember how to do that. Well, don't be too afraid. First thing I'm going to say is what goes into each of these that I can pull out? An x. I can pull out an x out of every part. Oopsie noodles. Sorry for the language. Aha. This one, I am going to try to factor. Well, it's only 13 and 1, and they don't add up to -6, so it's not factorable. So what I'm going to have to do is quadratic this beast, quadratic equation. So x is going to be equal to my opposite of b, plus or minus square root of b squared minus 4ac all over 2 times 1. Okay? When I calculate that out, I get 6 plus or minus square root of -16 over 2. Now, what do I do with this -16? Well, isn't that the same thing as square root of 16 is 4? Square root of -1 is I. All over 2, right? I can factor it down one more time. Divide them all by 2, right? 3 plus or minus 2i. Now, I have another solution too. Don't forget about this x up here. Because I'm finding out when does this equal 0, right? For my factors. If I think about it that way. So x is another one. Or, I'm sorry. 0 is another one. So these are my factors. 3 plus 2i, 0, 3 minus 2i. So to write this in factored form, I would do x, minus 0. X minus 3 plus 2i, and x minus 3 minus 2i. I'm just plugging in my zeros. That's my factored form. I can simplify this a little bit. It's kind of messy. X minus 0 is x. This would become x minus 3 minus 2i. And this would become x minus 3 plus 2i. What fun that was. Pretty gross, right? But let's keep on trucking. Let's do another one for funsies. Let's factor this beast. All right. Factor this one completely. Well, first thing I got to do is what do these both have in common? Well, they both have a y. So I'm going to pull out a y, right? Y times 4x squared plus 25. Uh-oh, Mamma Mia, I can't factor this one again. I can't factor this at all. So what I need to do is find the zeros of it, and that will give me my factored form. So now this piece is already taken out, so I need to take this piece and factor it. So I'm going to do it over here, kind of like a sidebar. So I'm going to do 4x squared plus 25 equals 0. Now how did I get rid of that 25? Yeah, subtract it from both sides. So I get 4x squared equals negative 25. How do I get rid of the 4? Divide it. So I get x squared equals negative 25 over 4. All right, last step there, my pre-calc homies. How do I get rid of a square? Square root it. Now, what's the square root of a negative 1? An I, right? Oh, don't forget your plus minus too, right? What's the square root of 25? 5. Square root of 4 is 2. So I get plus minus the square root, or not square root, of 5 halves I. So my factored form is y times x minus 5 over 2i, x plus 5 over 2i. All right, and those came from solving the other factorable part. We're just saying equals 0 and solving. All right, that'll give us a start. More coming tomorrow.